For the next few problems, we're going to be looking at evaluating a definite integral. This is discussed in section 6.4. Alright. So we have an upper and lower limit of integration, and we're asked to integrate this with respect to x. So let's find the antiderivative of this first. So if I'm going to find the antiderivative, I'm going to integrate each of those terms separately. So I'm going to go ahead and rewrite it using the techniques that we've used before, separating each term into its own integral. With respect to x, we're going to integrate each one. So we end up getting 2 times x to the 4th divided by 4 minus 3 times x cubed divided by 3 plus x. And then once we find that antiderivative, we said we want to evaluate it at the upper and lower limits of integration, so between 0 and 1. Simplify a little bit before we do that. 2 and 4, that cancels out and gives me 1/4, x to the 4th divided by 2, minus, these 3's are going to cancel, I'm left with x cubed plus x, and so we're going to evaluate this from 0 to 1. And remember, when we actually evaluate, we put the upper limit of integration in first, so we're going to put a 1 everywhere that we have an x. So that's 1 to the 4th divided by 2 minus 1 cubed plus 1. So there's the upper limit of integration minus, remember we always subtract, and now we're going to put in the lower limit of integration. So we're going to put a 0 in place of x everywhere we see an x in the antiderivative. So that would be 0 to the 4th divided by 2 minus 0 cubed plus 0. And we're going to simplify and do the arithmetic here. 1 to the 4th is 1, so we end up with 1/2. 1 cubed is also 1, so minus 1 plus 1. And that gives us 1/2. Minus 0 to the 4th is 0. 0 divided by 2 is 0. Minus 0 cubed is just 0 plus 0, so from the entire second bracket there, we get 0. 1/2 minus 0, of course, is just 1/2. Okay, let's look at number 21. We're asked to find the definite integral from x equals 1 to x equals 3. And we're going to first, of course, find the antiderivative of what we're given. So we're going to find the antiderivative of, I'm going to go ahead and bring out the 2 as the constant, and I'm going to integrate 1 over x dx. Of course, that's going to give us 2 times the ln of x, and we're going to evaluate this from x equals 1 to x equals 3. We're going to put the 3 in place of x. So 2 times the ln of 3. So we're going to evaluate first at the upper limit of integration, minus. Then we're going to evaluate at the lower limit of integration. So we're going to put in the positive 1 in place of x. So that would be 2 times ln of 1. And then we're going to simplify. Ln of 3 we don't know. So that's just 2 times ln of 3 minus. The ln of 1, so that's, remember what that's saying. That is saying that log based e of 1 would equal what? So we say e to what power would give us 1. And of course the answer for that would be 0. So what we really have now is just 2 times 0. And of course, 2 times 0 is 0. So we have 2 times ln of 3 minus 0, which of course is just 2 times the ln of 3.